So when you've got asynchronous data transmission, remember that means that the sender and the receiver are not in time with each other. So when you're doing this and you're sending data to another computer that's not in time, the first thing you need to realize is that there will be an agreed amount of bits that you are sending, okay, an agreed speed at which to send it. The reason is the timing devices need to be set at the same rate as each other to be able to successfully transmit data. Now, this can be one of two ways. So it can be done through what's known as the handshaking protocol, which again, we'll do a different video, where the computers agree how they're going to communicate the data before they send the data. So that's just a number of protocols, just a set of rules. Alternative for that, certain types of transmission have a already preset speed at which you need to use to send down that transmission. It very much depends on how it's going to work. But what's important is that computer, let's say we've got computer A communicating with computer B. Okay, the voltage on the wire will be at an idle state. So there will just be a set voltage. Doesn't matter what it is, but it's not a 1 or a 0. It's at what's known as idle. So it's this set voltage, which means nothing's currently happening. So what happens is the first thing is the sender will already have agreed how many bits they're sending and at what timing. Okay, this timing signal. The sender will send a start bit. Now, most of the examples I've seen, typically the start bits are 0 and the stop bits are 1, but it doesn't matter. What's important is it's not the idle. So 0 or 1's not the idle. And what happens is the start bit, if you imagine this is like a voltage level, so it's a straight idle, let's say it jumps to a 1, it's going to jump up here. Or if it jumps to 0, it's going to jump down here. But that change is going to wake the receiver up. Okay, so the start bit is used to wake up the receiver and realize to let them know data is being sent right now. So okay, it wakes up the receiver. The receiver then kicks in their timing device, which has already been agreed because they've got to send and receive the data at the same rate. So the receiver's been waked up. Then because it's waked up and it started the timing device, these bits of data here, it will read because it will know I'm sending, what's this, 8. I'm sending 8 bits across. So that's already been agreed. So it knows to expect 8 bits. And it knows the timing at which to read these 8 bits. So it reads those. And remember, it's been woke up by the start bit. Then the parity bit, I will have done another video on this at some point, but it won't necessarily be in networking. But parity bits is a type of error checking. So for those of you that don't know, parity, you have either odd or even parity. So if this is even parity, because the data contains 3 ones, the parity bit would be a 1 to make the number of ones even. If it was odd parity, the parity bit would be a 0 to make them 1. Again, it's part of that understanding that's already been agreed. So for this communication to take place, we're going to use even parity. I'm going to send you 8 bits at a time, that sort of thing. And then this parity bit is just used as a basic form of error checking. It's not perfect in any way, but obviously, if say there was only 2 ones, the parity bit is read as a 1, and we chose even parity, there's been some issue in that communication. Okay, so the start bit is used to wake up the receiver. It then sets the timing device in sync with what's already been agreed to read the data as it's coming down the wire. Then it will use the parity bit for a basic bit of error checking, and the stop bit is always the opposite of the start bit, which informs the computer that that is the end of that block, that packet of information that is being sent. And then it goes back to its idle state and it will wait to receive the next packet of information. So the key thing about asynchronous data transmission is that while they don't share a clock signal, they will agree on the speed or the timing at which to use in that data transmission, and they sync just for the time of transmission. Okay, so for 2 computers to communicate, they do have to be in sync. But if you don't share any form of timing signal as you do in synchronous communication, if you don't share that, it's known as asynchronous communication. That basically just means that you just sync for the period of that communication only, and then you go back to as you were, sort of thing. I hope that makes sense. It's a bit of a odd topic section, this, but the key thing to remember is this idea of this idle state, this idle voltage level. The start bit wakes up the receiver. The amount of data that and the odd and even parity, etc., has already been agreed, and the timing prior to communication taking place. Look into handshaking protocol for a common way that that's done. So you've got the start bit waking up the device. It will then set the timing to the agreed timing signal to read the data. It will read the parity bit to do some basic error checking. And then the stop bit is always the inverse of the start bit. And then you can go back. It will go back to that idle state and ready for the next receiving of the next packet.